In this lab, we will use this template, which is provided through Canvas, so that you can download the template and fill out this. The lab is about Ohm's law, resistor and resistor combinations. There are parts in this experiment. In fact, this is a simulation, so a simulation experiment. In the part 1, we will try to verify Ohm's law by doing some current and voltage measurements. In the second part, we will connect the resistors in series. In the third part, we will connect resistors in parallel. Since you know the theory about Ohm's law and the combination of the resistors from the lectures, I will skip the theory. Let me show you the simulation in this experiment. At the top of the worksheet and at the beginning of the first part, there is this link. While you are pressing and holding the control key on your keyboard, when you click on this, it will bring to you the simulation. And the simulation looks like this. In fact, this is HTML-based web page simulation. This is the circuit simulation. There are two boxes on the left and on the right. On the left, we have wire, battery, light bulbs, resistors, switches, fuse, another battery, etc. There are other things also. But you have to first get yourself familiar with building up a circuit in here. What you do is just press while you are using the left button of your mouse, drag it, first press on the tool that you want to work, hold it and drag it onto this blue region. I just did this for a piece of wire. If you bring a circuit element to the blue ground, you can tap on it by the left key of your mouse, and then what appears on the bottom of the page is a box, which, for example, for this element, shows the voltage. You can adjust the voltage by this voltage slider to any value you want, to any value between 0 and 120 volts. Let's keep it 10 volts. And what this is? If you press on this, you just change the polarities. The orange part is the plus and the black part is the negative. And if you press on this, what you use over here is the eraser. You just press on it to delete the battery, the circuit element. I mean, you just get yourself familiar with these things. The other thing is that you see these parts, end parts of the elements. You can grab from these parts. For example, for the wire, it doesn't have any different effect. It just makes the wire length longer or shorter, whatever you want. Similarly, you can drag the other end, free end of the battery like this. If you click once in the connection point between two circuit elements, this appears. A scissor, which means you can cut it so you can just break the connection. If you bring it, you make the connection. It's connected now because if you hold this connection point, both the wire and battery come together, move together. So that means they are connected. Let's go back to the report. So the procedure for the first part, what you will do is you will just construct this circuit diagram, which consists of one battery, wires, and one resistor. So what it says over here is click on the battery symbol in the bottom right of the screen, etc. So on and so on. We can all read out this. What is requested from you here is just construct this circuit, which consists of a battery and a resistor. And there are also measuring tools like voltmeter, which reads potential differences. It's connected parallel to any part of the circuit, and where you connect the voltmeter, it shows the potential differences at the ends of these parts of the circuit. What's asked in the third step is connect the two terminals of the voltmeter with the endpoints of the resistor. The next step, connect the ammeter with the circuit in series. As you know, ammeter is connected serially to any part of the circuit. And where you connect the ammeter, it shows the current that passes through this part of the circuit. After constructing the circuit, you will fill out a data table, and then you will make a plot of this data table, just like VI, voltage versus current. If you plot the V versus I being independent variable horizontal and V being dependent variable vertical axis, and then make a plot. It will be a straight line graph. The slope of the straight line graph in that case, if you think V is equal to I times R, gives you the resistor. If you measure the slope, you will get the resistor value in the circuit by measurements and using the Ohm's law. So you will verify the Ohm's law. What you can do is to construct the circuit diagram and choose any voltage and the resistor value. Fix the resistor value. You can always increase or decrease the voltage value of your battery by sliding the control button. When you change the voltage, you will just measure the current through the resistor by using a meter and read out these readings, like we can start with 3 volts, let's say, and just measure the current through the resistor, record it 3 volts versus this much current. Increase it to 6 volts, again measure the current, record it, etc. By this way, fixing one resistor and changing the voltage value, and by running for each change of voltage value, you can fill out the data table. The data table, like this one, each time you will change the voltage value. For that voltage value, you read out the current value. and calculate the resistor using this formula V divided by R. Another voltage value, read out corresponding current value and calculate the resistor from V divided by R, and so on. And then you will make a plot of V versus I from the data of this table. Make a plot by, you can use Tracker, you can use Excel, whatever you want, but the graphing software that you are using should be able to calculate the slope of the graph. The Tracker does this, as you know. Then what you will do is, you will make a plot in this data in part 1. That part is about verifying the Ohm's law, and you will comment on the results. Once you make your own plot, you just put this plot over here, paste your graph over this region. Let's try to build the circuit first. I will show you how to build this circuit by using this circuit simulation. As I said, we had one battery. Make another wiring over here. You can also put another wire over here, like here, and switch maybe. How the switch works? If you press on it, it will close the circuit, and press on it once again, it will open the circuit, etc. So, one wire over here, one wire over here. For this part, you will add the resistor and again a wire over here, and this wire will close the circuit over here. So it's just a simple circuit which consists of one battery, one resistor, and this is just a switch. The other thing is on the right side you see. First of all, a box which ticks shows current. Obviously, when you close the switch, you will see that the current is flowing. What you see over on the wires, you see electrons, motion of the electrons like this. It's kind of representative motion. Of course, in reality, this motion is very fast. You will not be able to see it like this. You can switch this mode between the electrons and conventional. Conventional simulation that shows the flow of the current is going in this way. What you see is the current flows in opposite direction to the electron flow, as you see. Because we take the direction of the current as the flow of positive charges, but there are no positive charges moving on the metals, only electrons can move. So, wherever the direction of the electron goes, the direction of the positive charge, of course, will be opposite. What you see over here is the direction of the current I. It is not the direction of the flow of the electrons, just the opposite. The red arrows shows the direction of the current. It always starts from the positive terminal of the battery and ends on the negative terminal of the battery. Let's stay like this. And these are labels. These are values. Values shows you if there is a circuit element like the resistor over here. On the top, it shows the value of the resistor in units of ohm. For example, the resistor is just 10 ohms and the battery is 9 volts. And there is nothing over here because it's just a switch. And this kind of circuit is in fact a little different from the real circuits because the wires on this simulation doesn't have a resistance. But in real life, all wiring, even if it's very small, it has some resistance. Anyway, we can ignore this while verifying Ohm's law because it has very little effect on the Ohm's law, the resistor for the wires. Next is just grab the voltmeter from the right. This voltmeter has two probes. Always using a voltmeter goes like this. Positive terminal will be attached to the positive terminal of the device that you are going to measure the voltage difference between its endpoints. For example, the device that we want to measure the voltage across the resistor because what you will draw is what you will read out is the voltage across the resistor versus the current that flows through the resistor. This will show the voltage when you make this connection. The positive probe, which is the red probe, put on the positive side of the resistor. In fact, resistor has no any polarities, but when you connect it to the circuit like this terminal of the resistor is just the plus terminal because it is connected to the plus terminal of the battery. And this terminal is negative terminal because it is connected to the negative end of the battery. And if it's so, how you connect the voltage across the terminals of the resistors goes like this. Black probe will always be connected to the negative terminal of the resistor and the red one is connected to the positive terminal of the resistor. As soon as you make this connection, you read out the potential difference between the terminals of the resistor. This is the potential difference between the terminals of the resistor. But over here, since there is no any other circuit element other than this resistor, This potential difference is just the potential difference provided by the battery to your circuit. But if there were other resistors over here, this value would be different than the battery's voltage. You will see later this. So this is how you measure the voltage. Next, ammeter. To read out the current that flows through the resistor, you have to connect the ammeter in series to the branch of the resistor. But in order to do that, you have to replace this piece of wire by the ammeter. So let's stop the current over here, break this piece of wire at these points. So erase it and then bring this ammeter in series and make this connection. So it's 0 because there is no current flowing because the switch is open. And once you push the switch on, you close the circuit and you read out the current. The current value going through the resistor is going to be 0.9 amperes. So this is the way. I mean, how you fill out this table over here. Let's switch the animation again. You can start a voltage value of, let's say, 3 volts. Okay. So you start in 3 volts. Come over here. Your first voltage value is 3 volts. And corresponding current value is going to be read from here. It is 0.3 amperes. So 0.3 will be recorded just over here. So this was 3 and corresponding value was 0.3. So then what you do is just go over here, simulation again, and change the current voltage provided by the battery to, let's say, 6 volts. And come over your table, put over here 6. 6 volts of battery voltage or 6 volts of potential difference across the terminals of the resistor. Corresponding current value for the resistor is 0.6 amperes. So come over the table for this 0.6 ampere of the current. So this way you just make 5 different readouts by given 5 different voltages for the battery, and each time you just read out the current value through the resistor. You record them, make this table, and then This table will be plotted V versus I, and from this plot, you will see the data will look like just a straight line. But it has some slope. Calculate that slope. This is going to be resistor value in your circuit, and you will verify Ohm's law. So that is the finish of your first part. The other parts in your report, I will leave it to you. And the other parts, what you will do is, you will construct these series and parallel circuits. For example, for these resistors, which are connected in series like this with one battery, you will make some procedures. You will some readouts, etc., which are going to be filled over here in the second part, series connection part. You will just work on this part, whatever it's asking to you, whatever it is asking you to do, just any measurements, any calculations, you will fill out these parts. And the parallel connection similarly has parts to be filled out by using your simulation, and you will again do some graphs, etc. In the end, answer these questions. There are 3 questions. Then complete your report. That's it. This is your second experiment.